Hello everyone, welcome to SHR Trinity. In today's video, we are going to walk through 10 of the most important machine learning interview questions of this Part 1 series. Data science, artificial intelligence, machine learning, and data analytics are among the most sought-after career paths in today's technology-driven world. One common skill required across all these roles is machine learning. However, machine learning is also one of the most challenging areas in technical interviews because it requires a strong understanding of concepts, algorithms, model evaluation techniques, and real-world problem-solving approaches. To help you prepare effectively, SHR Trinity brings you the Machine Learning Interview Questions series. In this series, we cover the most frequently asked machine learning interview questions from basic to advanced level with clear explanations, practical examples, visual diagrams, comparison tables, and interview-focused insights. Whether you are preparing for data scientist, machine learning engineer, AI engineer, data analyst, or software developer roles, this series will help strengthen your machine learning knowledge and interview readiness. Keep your notebook ready and make notes as we go through these important concepts. Before we get into the video, subscribe to SHR Trinity and hit the bell icon so you never miss any updates from our end. So let's begin with our very first question. Before we dive into the questions, let's look at what we'll be covering in this video. We will discuss 10 fundamental machine learning questions. We'll start with definitions and types, explore training data and features, learn about regression and classification, and deep dive into overfitting, underfitting, and the bias-variance trade-off. This section lays the groundwork for all future machine learning concepts. Let us start with question 1. What is machine learning? In traditional programming, developers write explicit rules and combine them with data to produce output. In machine learning, we feed the computer both historical data and desired output, and the algorithm itself discovers the rules and patterns. Machine learning is a subset of artificial intelligence that focuses on building mathematical models capable of generalizing from past experiences. It is iterative in nature, meaning as more data is provided, the model's predictive accuracy increases. The typical workflow starts with data collection and cleaning, followed by model training, evaluation, and deployment. Question 2. What are the types of machine learning? We can break machine learning down into 3 primary categories. First, supervised learning. Here, the dataset is labeled. The model is given inputs along with the correct answers, like mapping emails to spam or ham. Second, unsupervised learning. The data has no labels, and the model attempts to find organic patterns or groups within the data, such as segmenting customers based on purchase behavior. Third, reinforcement learning. An agent learns to make decisions by performing actions in an environment and receiving rewards or penalties, similar to teaching a robot to walk or training an AI to play chess. Question 3. Supervised learning versus unsupervised learning. Look at the comparison table on screen. The main difference lies in the presence of labels. In supervised learning, every training instance has a target label, allowing us to compute a direct error or loss to guide optimization. The goals are regression or classification. In unsupervised learning, there are no target labels. The model explores the data to identify similarities and differences. The goal is clustering or dimensionality reduction. While supervised algorithms predict customer churn or stock price, unsupervised algorithms detect anomalous transactions or group similar products. Question 4. What is training data and testing data? Think of training data as your textbook and class exercises, and test data as the final exam. During training, the machine learning algorithm examines the training dataset to learn patterns and adjust its weights. If we evaluate our model on this same training dataset, it might look perfect simply because it memorized the answers. To measure true performance, we set aside a testing dataset. This test data is kept completely hidden from the model during training, serving as an unbiased evaluation of its ability to generalize to new inputs. Question 5. What are features and target variables? In any tabular machine learning dataset, you will have inputs and outputs. Features, denoted as capital X, are the independent input variables. For example, if you want to predict house prices, the features would be square footage, number of bedrooms, and age of the house. The target variable, denoted as lowercase y, is the dependent outcome we want to predict, which is the price of the house. Look at the code on screen. Using pandas, we easily slice our data frame to separate the independent features columns from the dependent target column. Question 6. What is regression? Regression is a form of supervised learning where the model's job is to predict a continuous numerical value. If your target is a floating point number or an infinite range of quantities, you are solving a regression problem. Examples include predicting the future price of a stock, tomorrow's temperature, or the revenue of a company. The goal of regression models is to find a mathematical relationship that minimizes the distance between predicted values and actual coordinates, evaluated using metrics like mean squared error. Question 7. What is classification? Unlike regression, classification deals with discrete categories rather than continuous values. The model's objective is to assign an input instance into one of several predefined groups. If there are only two categories, it is a binary classification problem, such as classifying a transaction as fraudulent or legitimate. If there are more than two categories, it is multi-class classification, like recognizing digits from 0 to 9 in handwritten images. The output is typically a probability distribution over the classes. Question 8. What is overfitting? Overfitting is a common pitfall in machine learning. It occurs when your model learns the training data too well, memorizing the noise, outliers, and random fluctuations instead of the actual underlying patterns. While it performs exceptionally well on training data, its accuracy drops significantly on new, unseen testing data. This happens because the model's complexity is too high for the available dataset. To prevent overfitting, you can simplify the model architecture, use regularization techniques like lasso or ridge, or collect more training examples. Question 9. What is underfitting? Underfitting is the opposite of overfitting. It happens when the model is too simple to capture the underlying structure of the data. As a result, it performs poorly on the training set and the test set. An example of underfitting is trying to fit a straight linear regression line to data that clearly follows a quadratic curve. The model lacks the capacity to represent the relationship. To address underfitting, you can introduce more features, select a more complex algorithm, or reduce regularization constraints. Question 10. Bias versus variance. Look at the comparison table on screen. In machine learning, generalization error is composed of bias, variance, and irreducible noise. Bias measures the difference between our model's average prediction and the correct target. High bias implies the model makes overly simplistic assumptions, leading to underfitting. Variance measures how much the model's predictions change when trained on a different dataset partition. High variance indicates the model is highly sensitive to the training set's noise, leading to overfitting. Balancing this trade-off is key to building successful models. Thank you for watching. If you found this video useful, please subscribe to SHR Trinity for more videos, and click the like and share buttons. Stay tuned for part 2, where we will cover core machine learning algorithms. If you are interested in attending our live training sessions or have any inquiries, all our contact details are displayed right here on screen and are also available in the video description below. Feel free to reach out to us. We would love to have you as part of the SHR Trinity learning community.